So today we learn about the oscillatory motion. When a body which is displaced from its mean position, then the body perform oscillatory motion along the same path in to and fro direction. So that time this particle or this body having certain velocity, displacement and acceleration. So question is here, obtain an expression for acceleration, velocity and displacement for a particle performing linear SHM by using differential equation. So we know that the differential equation of linear SHM is given by d square x by dt square plus omega square x is equal to 0. So by rearranging this equation, we can write here d square x by dt square is equal to minus omega square x. But here d square x by dt square is equal to a. It is represented by capital A. Here acceleration of a particle performing linear SHM. So therefore this above equation becomes a acceleration a is equal to minus omega square x. So this is the expression for acceleration of a particle performing linear SHM. Now to obtain the expression for velocity. Now rearrange equation number 1 in the form of velocity. So we know that by the definition of velocity and acceleration, v is equal to d square dx by dt and acceleration a is equal to dv by dt. The rate of change of displacement with respect to time, and acceleration is defined here the rate of change of velocity with respect to time. So multiply and divide both sides by dx. So by rearranging this value, acceleration a is equal to dv by dt multiplied by dx by dx. So replace this dx by dt. So therefore acceleration a is equal to dv by dx multiplied by dx by dt. But we know that this is the velocity of a particle. So therefore dx by dt is replaced by v. So therefore acceleration a is equal to v dot dv by dx. Put this value in equation number 1 in place of a. So therefore equation 1 becomes, we can write here v dv by dx is equal to minus omega square x. So therefore v is equal to v dot dv is equal to minus omega square x dx. Now integrate both sides. So therefore integration of v dv is equal to minus omega square integration of x dx. But we know that integration of v dv is equal to v square by 2 is equal to minus omega square x square by 2 plus c, where c is the integration constant and its value is determined by considering the extreme position condition. So what is the extreme position condition? We know that when a body which is performing oscillatory motion, so that time the maximum displacement from the mean position is called as amplitude. So that time at extreme position x is equal to a, and at the extreme position velocity of the particle or body is equal to 0. So put this value in equation number 2. So therefore equation 2 becomes 0 square upon 2 is equal to minus omega square a square upon 2 plus c. So therefore 0 is equal to minus omega square a square upon 2 plus c. Therefore c is equal to omega square a square upon 2. Put this value in equation number 2. So therefore v square upon 2 is equal to minus omega square x square upon 2 plus omega square a square upon 2. 2 cancel. Therefore v is equal to omega square in bracket a square minus x square. Therefore v is equal to omega under root of a square minus x square. So this is the expression for velocity of a particle performing linear SHM. Now to obtain the expression for displacement, by the definition of velocity we know that v is equal to dx by dt. So therefore equation 2 becomes here dx by dt is equal to omega under root of a square minus x square. Now rearrange this equation here, x of whole dx under whole divided by under root of a square minus x square is equal to omega dt. Now integrate both sides. Therefore integration of dx divided by under root of a square minus x square is equal to omega integration of dt. Now we know that integration of dx divided by under root of a square minus x square is equal to sine inverse x by a. So therefore sine inverse x by a is equal to omega t plus alpha. So therefore x by a is equal to sine omega t plus alpha. Therefore x is equal to a sine omega t plus alpha. So here alpha is the integration constant and it is called as initial phase of a particle performing linear SHM. So in this way, equation 4 represents the expression for displacement of a particle performing linear SHM. So in this way, we derived here three equations for acceleration. A is equal to minus omega square x, velocity v is equal to omega under root of a square minus x square, and displacement x is equal to a sine omega t plus alpha. And it is very important for numerical point of view.